Well, I want to welcome you to the last of the four modules that are meant as a quick kind of brush-up study guide for the Test 1. If you've been listening to all of these, you know what's coming next. Just a reminder that these are not an exhaustive list of everything that might be on the test. They're just particular slides or summary slides that I thought were worth hitting one last time to kind of provide you some additional information to help you when you're studying. Again, the test itself is being drawn from the entirety of the lectures, from the textbook readings that support those lectures, and that the study guide that's posted on Blackboard is your best source to go to determine exactly what's going to be on the test. So, as the validity slides are also online, I'm probably going to spend a little less time on these, but just as a reminder that once we have reliability, we've used various methods to determine that a test is reliable. The next thing we want to do is validity. And validity is the estimate or judgment of how well a test measures what it purports to measure. So now we're asking the question, not are we reliably measuring something that's stable, are we actually measuring what we think we're measuring? And validation refers to an entire process of gathering and evaluating the evidence about validity. And there is no one method here. We usually use an entire set of both methodological, logical arguments and also statistical techniques. So, construct validity is, are we actually measuring the construct that we're actually interested in? Are we actually getting at the construct that we want? A couple of things to think about broadly in construct validity is we are worried about construct underrepresentation. So that's when we don't have enough items to actually measure the construct in its totality. So if we're claiming that we're measuring extroversion with a single question, you like to go out to parties. Well, extroversion isn't just about going out to parties. Someone might dislike parties, but is still very extroverted. So that would be underrepresentation. We're also worried about construct irrelevant. Are we asking questions that are irrelevant to the construct? So for instance, if I ask, do you like the color blue? Probably irrelevant to extroversion or introversion. We can also talk about face validity, which is a judgment call. Basically, do the items have the appearance that a test measures its intended construct or target? And also we can talk about content validity, which is basically simply, is there enough? It's kind of similar to construct underrepresentation and irrelevance, but underrepresentation refers to the fact we don't have enough items. Irrelevance is the items we have aren't actually measuring the construct we're after. Content validity is a little bit more of, do we have just right? Do we have enough items that we're capturing all of the aspects of the construct that we're actually interested in? We also have a whole set of statistical methods, which is criterion-related validity. So construct validity, face validity, and content validity, though there is some methodological ways we can basically poll experts to ask them their opinions, for the most part it's a judgment call or a series of well-reasoned determinations. Criterion-related validity is we're now actually, again, turning to our friend the correlation to compare our test to other tests. So again, our test has to be something that's continuous data, either responded to intervally or ratio, so you have a final score that's interval or ratio, and that we can then compare to some other interval or ratio data. There's three broad types of criterion-related validity, though I have a fourth listed here, discriminant validity. Though discriminant validity is kind of reversed. It's basically making the argument that we have validity based on a criterion that is not related to our construct. So the first three are all about actually, is our construct related to similar constructs? And the difference here is they're all correlations. It's just how we do them. So a predictive validity, criterion-related validity, means that we take our measure, we give it to a bunch of people, and then we wait for what we would be planning to predict. So if we had created, for example, a measure that's meant to find out if you'd be a good employee, we would give it to 30 people, we'd hire them, and then we'd wait for 6 months to find out, were they good employees or not? Once we have their employment performance data, we'd run a correlation between our predictive test and their correlation test. And if we found a strong relationship, that would be an argument that we are indeed measuring what we thought we were measuring. When you take a predictive test to get into college or grad school, like the ACT, the SAT, the GRE, these are again validated with predictive validity studies. If we give people the ACT and we find later that once they're in school, the people that scored very highly on that test are the ones that are getting high GPAs, and the people that scored poorly on the test are the ones getting much worse scores, we know that we have predictive validity. Concurrent validity is that we give our test to a similar test with the same measure at the same time. So in this case, we're basically comparing our score, our measure of extroversion, to an existing measure of extroversion. And usually it'll be the same methodology, so self-report to self-report. So there's no time gap here, and you need two tests, your test and a test that's similar. And this, in fact, is the way we're going to validate the measures that you're designing in this class, with a concurrent validity study. Convergent validity means we take your measure, this measuring a construct, with a particular methodology, let's say self-report, and we're going to compare it to a measure of that same construct using a completely separate measure or method. So, for instance, we have your self-report measure of extroversion, but we're going to compare it to a clinical psychologist's evaluation of how someone's behavior indicates whether they're extroverted or not. And then again, if we find a strong relationship, that means that the two methods are converging on the same construct. Further evidence of criterion-related validity. Discriminative validity just means, again, we're not waiting in time. We're giving people our new test, our test of a construct, but we're also giving them a separate test of a completely unrelated construct or a construct that it should only be mildly related to. And again, we're looking to see if it shouldn't be related at all, do we find a very small correlation? If it should only be related mildly, do we find a mild correlation? The more we find these evidence and the more we use, ideally, we'd want to use all of them. We'd want to do a predictive validity study, a concurrent validity study, a convergent validity study, and a discriminant validity study. And as all of these show patterns that indicate that it looks like we're measuring the right construct, we have a stronger and stronger argument that we actually have validity. We talked about the multi-trait, multi-method matrix, and again, the idea behind this is to combine all these concepts to basically do a concurrent and convergent validity study and a little bit of discriminant validity study at the same time. We're basically giving participants a series of tests. We're giving them multiple tests of two different constructs using multiple methods. Hence, multi-trait, two different traits, and multi-method, two different methods. And what we should find is that if we're measuring the same trait with the same method, that's where we should find the strongest correlations. If we're measuring the same trait but with different methods, we should find the second highest, and those are the green boxes. If we're measuring different constructs but using the same method, methods do have similar variance, so we'd expect to find moderate relationships, those are the blue boxes. And if we're measuring a different trait with different methods, that's where we should find the weakest correlations, and those are the H's. So this would be, in fact, a very good example that when you see this pattern of your red boxes being your highest, your next highest being the green boxes, the next highest being the blue boxes, and the final lowest being the H boxes, that's a strong argument for construct validity. Now, if you're asked to interpret one of these on this test, I should say that I'm not going to have it color-coded for you. So you kind of have to get an idea of where these diagonals are and how to actually apply this theory to looking at a multi-trait, multi-method matrix. We also talked about briefly the reliability-validity relationship and an unreliability of test adjustment. This is again something that we'll often do. And what it shows us is it's a way to calculate how strong our validity relationship would be if we had perfect reliability. And we do this to kind of determine, do we want to go back to try to make our test more reliable? So notice that when we were talking about reliability, I talked about the fact that 0.7 or higher is generally considered to be fairly strong. But 0.9 or higher is usually considered to be something we want for if we're making clinical decisions. Well, this kind of an adjustment is one of the things that lets us know that. The higher that reliability, the more we can trust the actual validity relationships, the predictive relationships. So we don't want an unreliable GRE if we're going to be making decisions on whether people get into grad school or not. So the equation here is fairly straightforward. We take the reliability of the test, so the reliability that we got when we were actually testing for reliability of our test. We put that on the bottom of the equation where we're going to take the square root, and we put the uncorrected validity coefficient from whatever validity study we did, whether that was a concurrent validity study, a convergent validity study, or even a predictive validity study. Once we run the math, what we're going to get is an adjusted R based on what the correlation would be for our validity study. So, for example, predictive validity, how much does GRE predict GPA? If our measure actually had perfect reliability.